everyone. I am ready to get started. So, if you're new to React, you might hear that on top of learning React, right, you have to learn Redux, you have to learn a CSS and JS solution, you might have to do server-side rendering, et cetera, et cetera, et cetera, and you have to learn all these things at the same time. And if you're new, it can be quite overwhelming because React in itself is different development pattern, and having to learn all these other things at the same time can be too much, right? And React is just a UI library. So you have to pick a library for fetching data, for managing state, et cetera, in order to create kind of a full framework that you can use. But how can you pick the right thing if you've never used it before, right? So what I want to do in this talk is I want to go through the different libraries in the React ecosystem. And first, I want to provide my opinion on the different categories in the system and which I believe you should prioritize first in terms of learning. And then secondly, I also want to give my opinions on, within each category, which one I think is kind of the best option to choose and why. So can I get a show of hands? How many people are actually developing in React right now? Show of hands. Okay, so about half the room or so that's perfect. For those of you who have been developing in React for a while now, hopefully there'll be a thing or two that you'll learn that's new. But if not, hopefully you'll at least learn from me a kind of a way to explain your rationale for why you chose one library over another besides, I just like it better, all right? So let's just jump in. But before, I want to talk a little bit about React, okay? So for those of you starting out, my suggestion is that you learn React and you learn React really, really well, okay? And that might sound obvious, but it's important to focus on React and just React first. Like you have to learn how to maintain state properly and leverage the virtual DOM or the reconciler so that you're not re-rendering too many times. And if you're coming from the kind of traditional MVC model, this like one-way cyclical data flow can seem unintuitive at first or counterintuitive. But then after you get through the basics of React, there's also new features that have been coming out the last 18 months or so, because React continues to evolve. So if you're doing React 2 years ago and you're now getting back into it, it's going to be very different. So there are advanced component patterns like presentational components versus container components. You also want to share logic with higher order components or render props or now hooks that have just been released. So there are error boundaries that you can implement in order to catch errors that came out in version 16 last year. And there are fragments and there are the context API, which were in 16.2 and 16.3. We can now monitor and optimize performance, which came out in 16.5. There's this new suspense system now in React that allows for auto code splitting, and that came out in 16.6. And then there are hooks that landed in 16.8 earlier this year, which kind of changed the way that we do React component development. So here's the simplest example of interactivity in React. And first, I'm going to show using legacy classes, okay? So here we have this little counter up here, and I just click the button right there, and it goes up, okay? I have a little line here that says hold for oohs and ahs, but I guess that didn't happen. Okay, anyway, so the first thing we do is we initialize the state to 0, okay, because the counter started out at 0. And then next, we render out the UI, specifically the input tag, with that value from state, okay? And since the initial value was 0, the input field will also be 0 when we start off. And then next, we click the button, and as a result of clicking the button, we call the handle click method that's in the class there. And inside of the handle click method, we call set state, which updates the state to be the previous value plus 1. And as a result of calling setState, what React does is it calls render again, but now with the new value of state. So we put this new value back in the input field. It went from 0, now it's 1, and now we have 1 when we click the button. And although it may seem like calling render again will destroy the previous UI and display this new UI, that's actually not what happens because of the virtual DOM and the optimization that it provides. So it only updates the actual things that's changed. So the div doesn't update, the button doesn't update, even the input stays the same, it just updates the value for us. And now with hooks, compared to classes, it's a way to do it with function components as opposed to class components. So now with hooks, there's no real reason to use classes anymore with your components. But hooks are backwards compatible in the sense that you can still use classes. So jumping in, we import useState from React, which is the way that we'll be able to manage our state. And then secondarily, we initialize the state calling the useState hook. And we initialize it to 0. That's what we pass to useState. We get back from useState 2 values in a kind of tuple, a 2-element array. And that's the value and then an updater function, which I've called setVal. Next, we render out the same UI again. So the input field is value, and it'll be 0 to start off with. Click the same button, but instead of calling a method called handleClick, we just call this closure called handleClick, which is defined inside of the function itself. And now we call setVal with the previous value plus 1. And what this does is it re-renders the function again, the whole function. But with the magic of hooks, when you call useState again, it actually remembers the previous value of the state. So it's not really a create state, it's a use state, and it knows that the value was 1. And now that's what we start, that's the value of val again. And we put that back into the input field there, and now the value is 1. So that's why it's called useState, not create state. And we re-render it again. And the cycle continues on and on and on. So that was a quick little overview of React. Obviously, if you haven't used React before, it wouldn't teach you React. But Justin is giving an intro later this afternoon in the UI UX design track. If you want to learn more about React, I suggest you check out his talk. Or if you already know about React a little bit and you want to go a little deeper, Anthony is going to talk about the virtual DOM and kind of how the efficient rendering mechanism works. So you can check that out. It's also at the same time as Justin's talk, but it's down in the front end track. Okay, so before we continue, can I get everybody to stand up? Please, can I get everyone to stand up? So I realize it's after lunch, and I already heard like somebody yawn at the beginning of this talk. So what we're gonna do is we're gonna do 10 squats just like this to get the blood flowing to make sure that we're awake during the whole talk, all right? So let's do it all together. Let's count out loud. You can count with me. All right, here we go. Ready? 1, yep, we're really doing it. 2, 3, 4, good job. 5, keep going. 6, we're almost there. 7, 8, 9, and 10. Way to go, great job, everyone. Yes, that was so exciting. Whew. Now we can really feel it. Okay, all right. So just to introduce myself formally, my name is Ben Ilegbodu. I'm a Christian, a husband, and a father. This here is my family. That's my wife, Rashida. We've been married for 9 years. On the right is our oldest daughter, Simone. She's 5.5. In the middle is our daughter, Avery. She's 3. And on the left is our son, Asher. He turned 9 months as of yesterday. And we are still trying to teach him to smile in photos. But he will get there, okay? We live in the San Francisco Bay Area in this small town called Pittsburgh. It doesn't have an H at the end, so just Pittsburgh with the G. I'm also a Google developer expert and a Microsoft MVP, both in web technologies. So in exactly 2 weeks, I'm going to be starting a new role at a company called StitchFix as their front-end architect, which I am super excited about. StitchFix is a fashion retailer, combines technology and data science with an actual human stylist together to deliver a personalized shopping experience. However, technically, I am still employed by Eventbrite at the moment, okay? So it's a little bit awkward situation. I already let them know, so it's not a secret that I'm spoiling on stage. That would be wrong. Yes, so I'm a principal front-end engineer at Eventbrite. We're based in San Francisco. Hopefully you've heard of Eventbrite because you bought your tickets through Eventbrite, but we're an online ticketing and events platform. And we've been using React since 2016 when we migrated from Backbone over to React, and we've never looked back. So the genesis of this talk came from building a React framework with the different tooling then and continuing on. Okay, so enough about me. Let's talk about this React ecosystem. I'm going to be covering a whole lot of stuff. I won't be able to teach individual libraries. I just want to kind of expose you to what's out there so that you can investigate later. Like I said, I'll give my own preferences. So I tweeted out a link to the slides already. So if you go to my Twitter account, BenMVP, you can find the slides there. You can follow along if you so choose, because there's going to be tons and tons of resources as we go through. Okay, so let's talk about tooling first. That's the first category that you have to deal with when trying to build your own React application. And there was a lot of that's the biggest complaint around React in the beginning was the tooling and having to get stuff set up because there's a lot of choice in this area. So I'll start easy, though, with the React developer tools. So they are super handy for debugging your React components. You can just browse the React component tree and you can see what your props are, what the state is. You're able to do performance debugging as well as of React 16.5. And it's available for Chrome, Firefox, as well as Chromium-based Edge. Not the stuff before, but Chromium-based Edge. So check that out. Also, the next thing is bundlers. So you're going to have to kind of decide which bundling system you're going to use. And there's a lot of players in this space. There's Webpack, which is the predominant one. But you have to use a lot of configurators and loaders to make it do exactly what you want it to do. Like Webpack has its own ecosystem itself with all its loaders. And then there's Rollup, which works specifically with ECMAScript modules, so import, export type modules. And it introduced this concept of tree shaking, right? Where in a file, all of the functions that are exported in there, only the ones that actually you use will get generated or get included in a bundle. But it transpiles individual files generally. It doesn't create one big bundle together. So it's best used when you're creating a library and you want to export it for other people to consume. Then there's Parcel. It's fairly new. It boasts of blazing build times. It's zero config, so that it has lots of functionality out the box, as opposed to Webpack, which is nice. There's Prepack, which is another tool as well that also boasts fast speeds. It comes from Facebook, and it tries to pre-compile computations that otherwise would happen at runtime. The website still says it's in early development. It's been saying it's in early development for the last 18 months or something, so I don't know what Facebook is actually developing. Maybe they're just using it in-house or whatever, but that's the case with that. And then there's Pico Web, which is relatively new. And what it does is it does all of the bundling in the browser. So nothing happens compile time. It all follows dependencies in the browser that way. And it also only works with ECMAScript modules. So I'll say go with Webpack. It has tree shaking. It has a whole ecosystem around it, lots of documentation. But I do kind of want to try out Pico Web and see what that's about. So if you do also want to learn about Pico Web, Drew is having a talk later today as well to go into how it works and how ECMAScript modules work at a whole. Okay, so then there's task runners to run build files and command line shell scripts. We have grunt, we have gulp as well, which were different ways of trying to manage all of these scripts, and they got really huge and became unmanageable. And then once your Webpack and all of its loaders were taking care of a lot of the stuff that you would normally have to use grunt or gulp for, so npm scripts became like the default for how to run these scripts. You really just needed a runner and let Webpack do the rest, or your bundler do the rest. So if you have simple scripts, you can use npm scripts, but if you have something more complicated, use gulp. It uses streams, and it's more of a functional approach that way. Then there's static analyzers, all right? And this helps you find bugs in your code before it actually is shipped out. So ESLint is the original one, and it was geared towards kind of making the code seem the same across all of the developers, but now it can actually catch common errors in your JSX and things like that. Flow and TypeScript are both type checkers. So Flow exclusively does type checking, whereas TypeScript is a type checker, and it's a superset of JavaScript. So TypeScript introduced classes before they were part of the ECMAScript standard in ES 2015. And it has interfaces, and it has enums and other things which JavaScript doesn't yet. So last year seemed to be like the year of TypeScript. Like everybody was talking about TypeScript, everybody was excited about TypeScript, and it continued on into 2019 as well. And TypeScript is getting better and better at handling all of the dynamic stuff that we do in JavaScript. So it's getting easier and easier to type things there. So, and the integration with TypeScript into Visual Studio Code, if you use that as your editor, is awesome. So I wouldn't suggest using TypeScript from the beginning if you've never used it before, but it's definitely something that will help you develop in your code and catch errors. So that's everything that you need to do in order to get your tooling up to date, in order to run a React app even before you write any code. And that's obviously that's a lot of stuff that developers don't really want to have to do in the beginning. So all of that got put together by the Facebook team into something called Create React App, which just gets your app started with 0 configuration. So you can do a lot of configuration with it, and you can still bootstrap it with custom things, but for the most part, you can just run it right out of the box. And it creates an optimized bundle for you for production, and it has a lot of updated infrastructure. All you have to do is just bump one little package, and you'll get new stuff that they release there. So I have a whole bunch of other resources that you can check out if you get the slides, and you can follow those links as well. Okay, so now we know how to build an app. We can write some React code. We have to make it look good because visuals are as equally as important as the interaction, all right? And I can think of at least 5 different ways that we can handle styling in React. The first one is global CSS. Now, you would use global CSS if you're migrating to React from something else, where you already had a system that was building the CSS somewhere else. It was already handling that. So if you're using something like Bootstrap or using something like Foundation, it would fall under this as well. So in the code, you would just reference the CSS classes that have already been defined in your markup there. So the p tag, for instance, has card __ message as the CSS class. And then you would write your CSS in this global CSS separately, that gets bundled separately by something else. And you would likely try to use Vim syntax or OOCS CSS in order to prevent namespace collisions there, because all the classes are going to be all together. And then similar to global CSS is component CSS. So it's very similar to global CSS and how it ends up being generated, but how you import it is that you import it in the component itself. Now you don't do anything with the import, you're just importing it, But as a result, that means the CSS will only be included if the component gets included in the app. So you have that little optimization going on. And in order for this to work, your bundler, like Webpack, is going to have to be able to handle importing CSS or Sass or whatever CSS system you're using. So if you create React app or if you use Webpack, there are definitely loaders to be able to handle that. So similarly, your code looks the exact same in terms of how you're including the CSS. And then in your component CSS, the separate file, you would still need to use some sort of syntax to prevent naming collisions, like BIM, for instance, because eventually all the CSS is going to be put together in one bundle. But hopefully, if you had written global CSS, you was still already modularized, so moving to component CSS shouldn't be too difficult. Okay, and then the third option is CSS modules, which are pretty cool. So there's lots to like about CSS modules, actually. CSS modules are very similar to component CSS, except that you actually import an object when you import the CSS module. And that object is a kind of a lookup object of class names to generated classes here. So now, instead of the p tag having a class name of card __ message, it's now this object CSS.message. And then what you end up writing in the CSS is very vanilla CSS. You no longer have to worry about namespacing. You can just write like very simple classes like root or title or image. Like imagine just writing simple CSS classes like that. That's atypical, I guess, in normal CSS, because you don't have to worry about collisions with CSS modules because it handles the collision prevention for you. It will end up generating CSS that looks like this with the namespace there and the hashes at the end of the CSS class name. And these are the class names that were actually in that lookup that was passed to the CSS object when you imported it inside of React. So similarly, you'll need a bundler to be able to handle this as well, but most of them can do that. Most of the modern ones can do that now. So far we've had global CSS, right? We've had component CSS and CSS modules. And they all leveraged CSS, which is cascading style sheets, the cascade. The folks who choose inline styles as the option are in the screw CSS camp, okay? They're tired of dealing with specificity wars, with like unexpected cascade, all that stuff. They probably have bang important all throughout the CSS because they don't know why this style is not being applied. And plus, if you have lots of dynamic styles that depend on the values of props, CSS can be challenging, right? And there was a big push for inline styles actually when React Native came out a few years ago because it didn't support CSS. All it had was inline styles. And there was this desire back then to share components between React Native and React, so only inline styles could be used. It turned out that that desire didn't really work out too well, but there was still a huge push for inline styles. So now the styles object that's being imported is just a JavaScript object that looks something like this, that's exported. And instead of using kebab case, like justify-content, it uses camel case, justify content, in order to name the properties there, because it relies on the JavaScript CSS DOM API. The problem, though, with inline styles in React is that it only supports what inline styles support. So that means no media queries, that means no pseudo selectors, no keyframe animations. Like all of those, the CSS spec has continued to evolve and has lots of cool things that we can do, but those are not available in inline styles. Yeah. So new libraries popped up to try to solve this problem in clever ways. And most take what's defined like as an inline styles, but map it to unique CSS classes. So you kind of get the best of both worlds. You get JavaScript scoped styling, but the full expression of CSS, which is nice. So there are a couple of players in this space, the most popular being Emotion, JSS, Styled Components, Radium. Emotion is the newest and is super popular, so I would suggest trying that one out. It's taken lots of learnings from the previous ones that have come. But really, if you're starting out, I would suggest using component CSS, where you just import the CSS file and write it separately. Because CSS and JS is a whole new API that you have to learn, and CSS should be familiar. But as you start bumping into the problems with CSS that I was describing, then you may want to try out a CSS and JS solution like Emotion. And then once you get comfortable with that, you can just use Emotion all the time. So quick example of how it looks. You can create custom components, custom styled components with Emotion. So here, in order to create the title component, it's a styled H2 that has a font weight, or for your message, a styled P. And then now, the render of the card component looks very, very semantic. We have a title tag, we have an image tag, we have a message tag. So that's pretty cool there. And in the end, what gets generated out is the same markup, same classes. It has auto-generated class names to make sure there are no collisions. So it actually generates CSS in the end. It just does the CSS. You don't have to do the CSS. Okay, so I have a bunch of styling resources there for you to take a look at as well. So let's move along. Let's move along to libraries that are needed for single-page apps. And there are like two main subcategories for single-page apps. First is data fetching. So your favorite, like batteries included JS framework, like Angular, for instance, has some mechanism for making AJAX requests. But React doesn't come with one because it's just the UI library, right? So the second you want to make a data request on a REST API, you need to figure out how to do it. So you could reach for jQuery, right, and call $.ajax. But then once you have jQuery with you, you might start using it in ways that will conflict with React. And jQuery is really big. So the two main options are to use the native fetch API that's in the browser, or the Axios library, or Axios, or however it's pronounced. So the fetch API, like I said, is native to the browser. It's promise-based, and you need to polyfill it for the browsers that don't support it, like IE11, if you're still supporting IE11. On the other hand, you have Axios, which actually existed before the native fetch API. It's also promise-based, and it works in IE11 because it's a library. And it includes aliases like get or post or delete, so you don't have to just make a normal fetch request and pass the method. But it also supports canceling requests as well, which don't yet exist in the fetch API because they don't exist in the promise spec yet. So I've actually never used Axios, to be honest. I've always used the fetch API and have been fine with that. So a quick example of how the fetch API works. So in using hooks here, it's window.fetch. And like I said, you can polyfill it to work. There's also a node implementation called node fetch. And there is a library called isomorphic fetch, which is a combination of browser fetch as well as node fetch together to run it in both environments, which we'll talk about a little bit later. So here it's just using useEffect, the useEffect hook, which replaces component did mount and component did update, and that's where we can make our fetch call to get the data, set the state, and then do some rendering at the bottom. So here are some links for you that you can check out later. And then there's also routing. So there's making requests, and then there's routing because you want to keep your UI in sync with your URL. And there are two main libraries here, React Router and Reach Router. React Router is the oldest one, and Reach Router is kind of a rethink of how to do routing. It was intended to be accessible by default. So for instance, if you transition the page, it will provide focus to the area of the app that changed when the URL changed. So the tab focus is right there, which is nice. And it has, you can do relative links instead of absolute links like React Router, not found components, stuff like that. So it's pretty nice. But it turns out that the two of them are going to come together in the future, in the near future, actually. So they're built by the same two group of people. So they're going to merge together. It's going to merge together as React Router. So it'll be React Router version 6 or 7 or whatever the case may be. But it will have an API similar to Reach Router. So their suggestion is if you have few routes and you're looking to pick one right now, go with Reach Router because it'll be a similar API and you won't have too many routes that you'll have to change and you could do it all in one commit. But if you have lots of routes that you're going to have, go ahead and go with React Router because you'll be able to progressively change or migrate to the new API because the API will be backwards compatible. So a quick look at Reach Router here. It's familiar JSX syntax. So you have a router component that wraps your whole app, and then you basically put whatever page level or screen components that you have. The difference is that you provide a path prop to the component, and the path prop is what decides which route gets picked. So you don't have to have this kind of separate routes thing. You just bake it all into your component hierarchy, which is pretty nice there. And then you can link using relative paths and stuff like that. Okay, so then the fourth area is forms. Now let's be real, no one likes building forms, right? But everything is basically a form when you break it down. You're taking some user input that you need to take in. And it's not that forms themselves are hard, it's that forms with validation is hard. Because the validation requirements are always different. Like sometimes you need form level validation errors at the top, or you need form element errors that are in line with each one. Sometimes you have synchronous validation like a regex, but then other times you have async validation because you have to look up if that email has been used before. Sometimes you have validation that depends on one field or validation that depends on multiple fields. You have errors that should show up immediately, like that email is in use error, or you have errors that should wait until they submit the button. It's like so many different requirements that you have to build into a form. And there are a number of libraries that are handling this. The first one is Redux Form. So Redux Form was the original one, but the problem with it is that you needed Redux. And we haven't actually talked about Redux now. So in order to use Redux Form, you now had to pull in this whole new library, which was unfortunate. And the library itself was really big too, because it depended on Redux, had all this functionality that was just baked into this big library. So Eric, the designer, the developer of Redux Form, decided to do a redo. And he called it React Final Form, because it's the final implementation ever of forms in React, okay? Ever. There's never gonna be one after it. So it has no dependencies, doesn't depend on Redux, and it has a very small footprint. And in fact, there's actually a base library called Final Form, which is framework agnostic. So if you're using Vue or Angular or any of those, it can work there as well. So it has a whole plugin architecture, and that's how it can then work with React. And since he had built Redux Form, he had all of these test cases for final form, so it's been very heavily battle tested. It's about a year or so old, maybe a little bit more. So the problem was at the same time, Jared, the creator of Formic, noticed the same problem with Redux form in that it depended on Redux. So at the same time as Eric was building React Final Form, Jared was building Formic, and they basically solved the same exact problem, and the implementations are basically more or less the same as well, if you compare them side to side. So there's pretty much feature parity. So really, it's just a matter of preference when it comes to this one. If you've used Redux form before, the API for React Final Form will be very familiar, so go ahead and use that. Otherwise, you can try out Formic as well. So let's move on to testing, everybody's favorite topic, right? Because we hate to write tests, but we love when there's tests there when we're refactoring something, especially when we don't know how it works, right? So there are a couple of testing utilities that exist. The first one, Cypress, is predominantly for end-to-end tests, so browser tests, happy path flows. It runs in the browser, but it's not slow or sucky like Selenium and WebDriver, okay? I couldn't think of a better word. But it could also be used as a development platform or to do TDD. Because you know how when you're implementing something, especially if it's like a deep user experience, you have to click this, open this, and then now let's see how it works. Well, you can write a Cypress test to do all that clicking for you so that each time you make a change, it'll do those clicking and then put you in that spot, and then you can see where you're at. So it's a nice workflow as well as actually creating tests for you as well. Enzyme, unfortunately, they don't have a logo. It's the most common, though. It's existed basically since React existed. It's created by Airbnb. It has a jQuery-like interface for inspecting your components and interacting with them. So we use it at Eventbrite. It provides tons and tons of utility methods for looking at the components without running in a browser, which is super cool. But a lot of those utility methods you really shouldn't be using when running unit tests because they ultimately end up testing the implementation details. And it's too easy to write bad tests. So Kent C. Dodds saw that problem and decided to create React testing library as a more narrow way to write unit tests. And it's gaining in popularity. I haven't used it yet, but it's definitely something that I played around with. I've seen a little bit. I haven't used it in an app, and I want to try out. So it encourages you to write tests kind of like your users use your product. So it's kind of like integration tests in that sense. But it can be used to run unit tests or even end-to-end tests. So let's take a quick look at how it works. So here is Jest plus the React testing library. So in this case, we have a button component. Maybe it's in your design system, like Emma was talking about earlier today. Buttons have lots of configurability. So here we just want to test that when you click on this button, it toggles a class that makes it active, puts it in the active state. So here we use get by test ID, which comes from React testing library. When you render out the component, and then you can find the actual tag because it has the test ID and the markup, and then we just click it like in the unit test. No browser needed, which is like still like mind-blowing to me that we can still do this and run fast tests because we don't need a browser. But to make sure when you're unit testing React components, you only want to test the logic that your component is doing via its public API. So you should never test what the value in state is or private methods or anything like that. You want to test what's rendered and then what, if you pass in any callback functions to it, how they're called and when they're called, and how many times they're called, all right? So Gleb, the VP of Engineering at Cypress, is giving a talk later today, right here in this room, about Cypress and how it can work. So if you're interested in testing, well, I mean, no one's really interested in testing, but if you're interested in knowing how to do testing better, I would say go to his talk today. And I've got lots of resources up there as well. Okay, so at this point, we have all we need to create a production level quality app, because we talked a little bit about React. We talked about the tooling, basically create React app, which helps build production level builds. We talked about styling solutions, single page apps stuff like fetch and routing. We talked about forms and how to validate forms, and then testing as well. But I have a little bit more that I want to cover because we're moving now into the needs of like larger scale applications, okay? So maybe your app might not need it right now, but if it grows, it gets bigger, you have more people on your team, that might be necessary. Okay, so now everybody's favorite topic, right? So up until this point, we've been implicitly storing all the data, the application data, in React components, and maybe possibly using the context API to pass things down so we didn't have prop drilling problems. But once the data becomes too complex, or you have too many components that want to update the data and listen to the data and modify the data, then and only then maybe should you use a data management library. And look, we're talking about Redux at step 6. So it's not React and Redux, and you got to do it together, but now at this part, that's what we're talking about Redux. So most people use Redux, to be honest, and there's been a huge backlash on Redux. I know the maintainers feel that as well, but I think it's mainly because people are using Redux before they really need it, and they're using Redux without knowing how it really works or the purpose it's trying to serve. So if you had a library like a Redux form that made you use Redux, then all of a sudden you're adding it when you didn't really need it. So Redux basically uses the concept of reducers to update your state. And you generate new state by making a copy of your state and then mutating that state and returning that back. So immutability is key with Redux. And it helps you kind of separate the update of your data from the thing that changes the data, which is kind of helpful. So MobX, on the other hand, instead of it being immutable in the sense, it uses observables that subscribe to mutations of the state. So you get to change the state with normal methods. Like if you do array.push, then it will listen to that happening, and then it will update the state that way. But really, it's quite possible that we won't need Redux or MobX. Like with the combination of React context plus hooks and the use reducer, we won't even need to use those two. So we reach for Redux when we want to easily get our data to multiple components. Well, the React context API can do that. Or we want to abstract manipulating our data so that it can be easily testable with reducers. Well, the use reducer hook does that. So we may not even need those Redux or anything like that moving forward. But just a quick look at Redux. Here is an example of a to-dos state. So I have this action. I want to add a to-do item. Instead of pushing onto it, I make a copy of it using the spread operator, and then I add the new item that way. But making copies of objects, especially if they're big, have a lot of data, or you have small memory constraints at scale, can be a problem. So immutability libraries popped up to try to solve this problem. So Immutable.js is the big player in this space. It's yet another library from Facebook. I've only used it a little bit because the API was pretty cumbersome. It creates entirely new objects like collections, dictionaries, instead of arrays or objects. And I found myself constantly switching back and forth between immutable objects and native JavaScript objects. Because in React, I don't care about immutable objects. Like my React is written such that I'm never mutating the data anyway, so I just want an array, a native array or a native object. I really don't want immutable in my React components. So Seamless Immutable tried to solve that problem. It still has special data structures, but they're backwards compatible, so they work just like arrays or objects. They just give additional functionality and prevent you from actually mutating the objects. But then Ember, a relatively newer library, took a completely different approach. So they don't use new separate objects at all. Instead, what you have is that it provides this helper function called produce. And you give produce the object that you want to mutate. So here we're passing state as the first parameter to produce, and then a function that performs the mutation that you want. Here's the anonymous function. So that function takes a parameter, or takes an argument called a draft, and on that draft object, you can do your normal mutations, like push or delete or whatever you want to do in order to solve your data transformation problem. And then what produce returns is the new value of your state, because it batches up all those manipulations into something that is optimized and then returns back the array. So you can actually do some fanciness with currying with produce, and you can actually make it your reducer, but you can check out the docs to figure out how all that stuff works. Okay, so let me wrap up real quick. So server rendering is important if you have SEO concerns or performance concerns here. And you can server-side render with Next.js or Gatsby, for instance. So Next.js being a full framework, Gatsby being a static site generator. And you can actually use Node and roll your own together. But if your backend is not Node, then you can have, there's more work that you have to do. And this video that I have here of a talk that I gave 2 years ago kind of explains it all. Okay, and then the last section is API optimization and having to deal with REST problems and making lots of calls. There's GraphQL and Falcor, which are two different competing ones from Netflix and Facebook. And GraphQL has two implementations, Relay and Apollo. If you find yourself with data request problems, you can try out Apollo to solve that as well. Okay, so that was a lot. Running out of time. I know for a fact that you didn't pay attention to everything. Like, that's just reality. You probably were on Slack or text or anything, or you fell asleep because I made you do squats. But here's a quick TLDR, okay? So for React, obviously you have React tooling, you use Create React App. For styling, you can use Emotion, but maybe try out Component CSS first. For routing, go for Reach Router. React Final Form for forms. Testing, use React Testing Library because it's pretty nice. App data management, try using the Context API and hooks instead of reaching for Redux or MobX. And for server-side rendering, use Next.js because it's a nice server-side library. And then last, Apollo for data things. Okay, so that was it. I flooded you with lots of information. Like I said, the slides are online, so you can check them out. You can visit my website or Twitter or things like that. I really appreciate you all coming to the talk. There were 20 other ones you could go to, so thanks.